excited to introduce Ethan. He is an ISSS officer, the co-president this year, I believe. And so he is going to give us a little presentation, well, a great presentation about how we could be a lot more cybersecurity conscious when we are building our software engineering projects. Take it away.
Cool. Yeah. Thank you for the intro, Neil. So let me make sure I'm sharing my screen correctly. Does everyone see these slides? Cool. All right. Yeah. So I'm going to talk a little bit about just kind of a secure approach to web applications, which are what I imagine most of you are building. So just very quickly about me. So I'm, like Neil said, I'm the co-president of ISSS this year, which is, I guess before that, I'm a third-year CS major at UT, originally from Palo Alto, California. Co-president of ISSS this year, which is the Information and Systems Security Society. And so if you all find the content in this presentation interesting, then you're more than welcome to come join our events, and our website is just ISSS.io. You can find more information there. And also, so most of the things I learned that are in this presentation, actually, I learned from working at Lumos Identity, which is where I currently work still. It's an Andreessen Horowitz-backed startup, and we're building an identity governance platform for enterprises. So more than happy to talk to anyone about that if anyone's interested, because I've just learned so much working in sort of small startup, security-focused environment. So I split this presentation into kind of three separate parts. So first, we're going to talk a little bit about why should I care? Why is security important? Then in the middle, we're going to do a little bit of a technical deep dive into some specifics about what you should keep an eye out for when building a web app. And finally, we'll conclude with a Kahoot and also some non-technical best practices that still contribute to kind of the security of your startup or product in general. All right, first of all, why should anyone care about any of this stuff? Like, it's just a bunch of math, it's hard, it's complicated, why? And so I know from experience that when you're starting on a new project or a product or venture, security is rarely the first thing that jumps into people's minds. Because I can imagine most of y'all would rather be, hacking or coding or, building your product, designing, conducting user interviews. All of those sound more interesting than security to a lot of people. But security really still plays a very key role in your ability to both sell and market your product. This applies to both consumer-focused products as well as enterprise-focused products. I mean, on the consumer side, think about how the conversation around user privacy has become sort of amplified in recent years. People are more aware of what tech companies are doing with their data, such as selling it to advertisers. So that's kind of the consumer side. And then on the enterprise side, companies want to know that they can trust you, right? And so, a lot of them will conduct independent security audits of potential vendors, which is you in this situation. And so to put it simply, you want people to trust you and your technology, and having some demonstrable level of security in your product and your system, and also being able to show it and prove it, goes a long, long way in building that trust with whoever your customer is. And this maybe goes without saying, but caring about security is also important because you don't want to get hacked. And so getting hacked can mean a lot of different things in this context. Think about things such as a malicious actor gaining access to customer data, or your own confidential data, or even being able to impact your web apps runtime directly by if they gain access to any of your system resources. And so a common attack you'll see here is hackers will get onto your compute instance and they'll start mining Bitcoin, and then AWS will ban you because that is totally against their terms and conditions. And additionally, I like to think about security, kind of like company culture, in that it becomes, as you grow, it becomes much, much harder to add on or change as a company increases in size or a product increases in scale. Because as you and your company and your code base grow, you're only increasing your potential attack surface area, which makes it even harder to lock down. And so the best solution here in my mind is to, build your products from the ground up with security in mind. And we'll take this, in a second, we'll start taking a look at what that means from a technical side. Finally, security isn't just a checklist item where it's a to-do item, you click done, okay, cool, we have security now, we're done. It's really not what it is. It's a constantly evolving process where, unfortunately, the attackers always seem to be one step ahead of the people writing the application. So this is where it really pays dividends to be proactive in your approach to security rather than reactive. And so there's an old Chinese proverb that goes, the best time to plant a tree was 20 years ago. The second best time is now. And so this was said, I think, several thousand years ago. So this wasn't as applicable then, but so I've kind of updated it that the best time to secure a web application is 20 years ago. The second best time is now. So now that's kind of why we should care. Let's talk a little bit about kind of more technical things that we should keep in mind. And so this graph here shows kind of a very simplified view of a typical CRUD based web application stack, which I imagine should be relatively similar and familiar to most of the applications and products you all are building. And so to be concrete, I'm also assuming, I'm assuming that your app has some sort of client, which is what the user is seeing. And this is normally either a native mobile app or a progressive web application, normal web application, or maybe even a desktop app, but I somewhat doubt any of you are building desktop apps. And this client has to communicate with some sort of backend web service that then coordinates work with your database, your key management system, your data store, kind of all those AWS-y components. And another thing to keep in mind here is that security is really, it's quite a situational thing, and that everything I'm going to tell you are sort of general guidelines, but there's really no sort of one size fits all solution. So my hope is that you're able to kind of take away some of these core principles from this presentation and incorporate them into your own system. But for example, if you're still in the rapid prototyping phase of your product, then some of this stuff may be a little bit overkill. Whereas if you're attempting to sell your software to any reasonable government, the things in this presentation will be woefully inadequate, because people have different bars of what they require security-wise. And so I know there's a lot going on in this diagram, so we're going to hone in and focus on each part individually. And I guess the final part here is that I'm assuming that everyone's using some sort of cloud provider like AWS or GCP, and that you're not hosting things on-prem, because it's quite old-fashioned to do these days. All right, so let's start with the client. So the client is, as I said before, it's what your users are directly interacting with. And no matter what form your client comes in, be it native mobile app, desktop app, et cetera, a lot of the core principles all kind of remain the same. And the first thing really to keep in mind here is that you should really assume that all of your source code is totally public to anyone who wants to see it. And you should assume this because it's pretty much true. You can right-click inspect element on any web page, you see exactly what's being done. And so this means you shouldn't try to be clever and practice what we call kind of security by obscurity, because they have access to your source code, and so any somewhat competent malicious actor could figure out what you're doing. And sort of one implication of this is, so even though it is public, so that's kind of a given, but that doesn't mean we should help potential malicious actors even more. And a concrete example of this is, I imagine a lot of you are probably using React or other similar front-end web frameworks for a lot of y'all's applications. And it's enabled by default is something called source maps. And so what this means, basically TLDR, is you write your nice React code, and then it gets transpiled into normal JavaScript that any browser can interpret. And by default, you're only sending the JavaScript, but the source maps allow you to sort of say, oh, okay, this bit of complicated JavaScript maps to this easy to understand React component. And so that's really good for debugging, but you really shouldn't be serving that in a production environment, because that just gives attackers one more potential thing to help reverse engineer your application. So let's make their lives harder, not easier. You should also sort of remain prudent with regards to any sort of state that you're leaving in the client. For example, you don't want to store things like plain text user passwords and a local cookie. And I guess also, speaking of cookies, you should also just make sure you're being reasonable about the configuration of cookies, such as your same site policy, the lifetimes on them, et cetera, things like that. And one more thing I want to specifically call out the importance of is CSRF tokens, which help prevent CSRF attacks on your application, which, long story short, would allow attackers to impersonate a real user. And I won't go into a ton of detail on these, since there's a lot of information out there on the web about why and how you should do this. But I just think it's important to specifically call that out. And you want to make sure you're doing it totally correctly too, because actually at Lumos, where I work, we were going kind of a SOC 2 audit period, and this is kind of the biggest thing the auditors found, that they were able to break our implementation of it. So we had to rewrite some of that core logic. And kind of following along the same vein, I want to give another shout out to the OWASP top 10 security risks. Their website can explain each of these 10 things far, far more eloquently than I can. So I highly, highly recommend taking a look at that. You can just Google OWASP top 10 and you'll find it there. All right, so now we have a super secure front end, but our front end is useless if we can't reliably and securely communicate with other parts of our system. And so I think backend is a little bit of a loaded term. And so when I say backend here, I'm specifically referring to components such as our compute instance, where the backend web service is actually running, as well as things like a database, a data store, or a key store, or more things depending on what all you're building. And so this communication between the front end and the back end is typically handled over HTTP, and it can be done using paradigms such as REST or GraphQL. I think Neil mentioned you all had a presentation on REST a few days ago. So that's just one method we can use of communicating between our front end and back end. And so an important thing to note here is we never want to talk directly to our backend web service. I'll talk a little bit more about what this means in the next slide, but basically we're trying to reduce our infrastructure's attack surface to make it as small as possible. And we can accomplish this by, instead, making our load balancer or a reverse proxy server like Nginx be the only part of our system that communicates with the outside world, including your clients, because your clients are all out on the open internet in this case. Next, it's 2021. You really don't have an excuse for not using HTTPS. So please do so. The TLDR here is that it ensures that folks can't listen in on the network and see exactly what sensitive data you're sending over the wire between the front end and the back end. So just please do that, if nothing else. And so something I'm sure that most of your products need to deal with is authentication. And so this is where things are going to start to get a little bit opinionated. So I'm going to try to give some pros and cons to each side. So kind of the first option here is to do what we call, rolling your own authentication, meaning that you yourself are going to write the code that handles, the username and password field. You're going to hash and salt the passwords and store them in your database. Or you can use a third-party option, a third-party authentication provider such as Auth0 or Firebase. And so I personally would recommend the third-party option because it's way easier to get set up. Firebase specifically is very nice to be able to add support for additional identity providers like Google, Apple, Facebook, etc. And it also ensures that your authentication is correct, for lack of a better phrase, assuming you trust the developers at those companies. And there's also some nice functionality that they expose, such as easily adding two-factor authentication, handling password resets via email. They also do some anomaly detection, where they can can throw up a CAPTCHA if it thinks a bot is trying to log into your website. Things like this are really nice, but they do come with their drawbacks, right? So that maybe maybe your customers don't want to have to trust a chain of third parties in order to use your app, which is essentially what you're doing when you're using a third-party auth provider. And in some cases, this can end up being less flexible than if you've done everything yourself. And writing your own auth can be nice because it's kind of the opposite. It's far more flexible because you're totally in control of everything. And it's a little bit of a less jarring experience for your user because they don't need to navigate to a different site. But it's also possible you get it wrong, though, is kind of the downside of doing everything yourself, and it's more work. So really up to you. I'd recommend third party. And then last point here is enabling rate limiting is actually a very, very simple action you can take to reduce the load on your system and kind of hinder an attacker's ability to try to DOS you, stands for denial of service. This means that if someone from a single IP is kind of flooding your application with requests, you can just cut them off and kind of keep everyone say, okay, each person can only make one request a second, which ends up being pretty reasonable in the grand scheme of things. All right, so I'm going to expand a little bit more now on my previous point about how we never want to directly communicate with the backend. And hopefully this diagram sort of makes that point a little bit more clear. And so notice how there's only one arrow entering this dotted line, kind of on the bottom left. And this dotted line here represents a private subnet, which is something that you can easily configure on AWS or Azure or GCP. And this kind of allows us to make the assertion that all of the components within the subnet can only talk to each other from within the subnet. And so this goes a long, long way towards kind of reducing, like I said, your potential attack surface, because now we really only need to worry about that one arrow coming in into the subnet and out of the subnet, rather than all the connections and relationships between components within your system. And next point is, although you can, and I think you should, easily offload your authentication to a third-party provider, you as the developer, so we're still responsible for what we'll call application level authorization. And so if we want to take a step back, authentication is saying, who is making this request? Like, can I pin this request to some person, some user in my system? Whereas authorization is concerned with, okay, is the person making this request like allowed to view this resource? Where a resource can be a certain row in your database, a secret, an object in a data store, anything like that. And so this is another thing where there's really no one button you can click to just enable authorization in your code. It's more of a very application dependent. But really what you should just keep in mind is whenever you're writing code that's handling user data, you should make sure you're correctly filtering any calls to your database or your key store, and just making sure that, okay, this person is allowed to see this specific resource. Again, it means different things for different products. It's very much a situational thing. So I'm going to spend some time now talking about this little key here. So if your application interfaces with any sort of API, and one I see super, super often is the Google Maps API, it's highly, highly likely that you have a handful of these API keys that you have, right, that you need in order to both authenticate and authorize your requests to that API. And these API keys should never, never be stored in your source code. And we'll talk a little bit more about why in a second. But the prevention mechanism here is to instead store them in what we call like a key management system, which is something all of the major cloud providers provide. Like I think it's called Secrets Manager on AWS. I forget what it's called on GCP. But this kind of gives you the assurance that even if your source code and your database is compromised, your sensitive keys are still safe. And this can be extended to, you can store customer data in there too. Just it's a safe place, assuming you trust Amazon. And this next point can be generalized to, you should sanitize your inputs. In other words, you should never directly execute anything that comes directly from the front end. And so this is the cause of like the classic SQL injection attack, which is one of the OWASP top 10 vulnerabilities. And this can be entirely mitigated actually using, like I would heavily recommend using an ORM, which I think stands for Object Relationship Model, to access your database rather than using raw queries. And so this is from, not only just a security perspective, but just a software engineering perspective too, that using an ORM makes your application more secure, but it also makes, kind of forces you to think about your data model a little bit more and kind of modeling relationships. It also just makes your code easier to read, write, and interpret. And so an example of kind of not validating input is last year, there was someone who was able to, they tweeted an entire novel in one tweet because Twitter was only checking the length of the tweet on the front end and not the back end. So he could just, kind of trivially go in and send this large payload, and it just, ends up having this huge tweet. So I think that's something they fixed pretty quick. But it's also kind of, goes to show that even, these, huge tech companies who everyone sort of assumes that they know what they're doing, they don't all the time, basically, is the TLDR there. So I'm sorry I don't have a cool diagram for any of this stuff, but we're going to take kind of a little bit of a step back now away from the purely technical approach and think more about kind of the human side of security. And again, all of these points might not apply to your project or product right at this moment, but I think they're still, important things to keep in mind. And the first thing is that ideally, not everyone should have permission to do everything kind of in your environment. This could mean pushing code. This could mean deploying to production. This could mean tweaking settings in AWS. It's a very broad statement, which it's meant to be. And it should, in fact, quite be the opposite, where people should only have permission to do exactly what they need to do to get their job done. And we call this the principle of least privilege, and you can easily enforce this on AWS using your IAM settings, which is identity and access management. And this is just because, once your product starts to gain traction and have users, ideally most of your developers shouldn't even be able to see the production database if it has customer data. So again, kind of depends on your product, exactly who you're selling to. This is especially important if you're trying to get certified for something like a SOC 2. It's very important to especially enterprise customers. And this also ensures that you can't have a disgruntled intern take down your entire application, because that ability should really only be possible for if multiple people sign off on it. Ideally, you're never bringing down your whole application. This is also more of a software engineering thing, less of a strictly security thing, but I always advocate for having a separate environment to test and validate your changes before you push to your actual production environment. So typically this is called a staging or a canary environment, and you want it to kind of be as similar as possible to your prod environment. So you deploy there first, and you validate things work, and you want to enforce this with like an IP allow list so that it's not just out on the open internet. Next thing, yeah, so you can also have your version control software help you secure your code base a little bit. So I think GitHub now has secret scanning and Dependabot enabled by default. I'm pretty sure, but I'm not 100% certain, but they're easy to enable. And so what secret scanning does is actually, so before we were talking about how you shouldn't have your API keys in your source code. So this is actually kind of an automated tool that will read through each of your commits. And if it sees a commit that contains a secret, it'll sort of sound some alarms, email you. And what you should do there is you should immediately invalidate that API key. And then you should generate a new one and then store it in your key store, not in your source code. So that's what secret scanning does. And then Dependabot is kind of a similar thing that it keeps track of the dependencies you have in your application, because modern web apps have dozens, if not hundreds, of dependencies that of course vulnerabilities are found in these all the time. And so it'll sort of ping you, like say, hey, you're one version behind on this dependency, and it's actually really nice. It'll open up a PR for you, just bumping the version number. Another thing you can do is enabling two-factor authentication on all of your kind of sensitive platforms, your GitHub, your Slack, your AWS. And in a perfect world, everyone would have like a YubiKey or one of these physical hardware devices. But even using something like Duo, which we have to use for UT, or Authenticator, or even like SMS is better than nothing, honestly. And so finally, this is potentially the least sexy of all the security related things in this presentation. But please make sure you're using a password manager and generating random, unique passwords for everything you're using, because weak passwords really are the weakest link in any organization's security. And so one of the biggest kind of hacks in recent memory was a few weeks or months ago, this like big SolarWinds attack. A large part of how that happened was that the root password on one of their big systems was SolarWinds123. And so don't think this is something that sort of happens automatically, because it really doesn't. Even in these huge organizations, like these mistakes are made and they can be catastrophic. So we can stop for a second, see if anyone has any questions. More than happy to answer. And then I made a little Kahoot that we can do, sort of test some of the knowledge we hopefully just learned.
Hey, Ethan. I'm wondering why you mentioned that, like, in a perfect world for two-factor authentication, people would have those like physical devices. Why would that be? Why do you think that would be like objectively more secure than Duo?
So that's I can't answer exactly from like why it's better than Duo. I can't answer it. SMS has a lot of flaws in it directly, where people can call AT&T and spoof your phone number, and then they start getting your texts. I don't have a perfect answer of why a physical device is better.
Okay, fair enough.
I have a question. So if all of us that we do have personal projects or like TPEO projects and things like that, what do you think is the best way for us to go back and kind of personally audit ourselves and like figure out where our biggest weaknesses are? Like, how do you suggest we go about doing that?
I mean, how big are a lot of your project? I guess there's still like, like 2 or 3 people working on them, or
Yeah,
kind of
something
So
like
yeah,
that.
most of the projects are definitely about 2 or 3 engineers working on them. But we are starting to like kind of finish up some of our recent projects and like ship them out to our like stakeholders and stuff. So like I want to make sure we have some kind of security checks we do before we
Yeah,
say
we
if they're
definitely
ready.
want to, in my opinion at least, revamp some of our auth services because we
yeah.
started off with custom auth. I never liked the idea of it, but I want to push for us to, for example, I'm doing a project outside of TPO, and
Hmm.
I use a very similar AWS stack that TPO uses, but
Yeah.
for my auth, I use Firebase.
Right.
So I take Firebase and I send it, like, I only use Firebase for the auth because it's free, and then
Yep.
I take the UID that Firebase creates, and I take all of the auth stuff that Firebase gives me, and I just
Mhm.
chuck it into an AWS database, right? Uh,
Yep.
because I just don't care for for Firestore. I just think it's bad, and I
Mhm.
think the AWS Cognito is also bad. So like take the both. I take each of the best worlds, right?
Right.
So I kind of want to push for us to do that.
Sure. Yes. I guess kind of address both points. I guess first, what you said about, yeah, you're using Firebase for authentication, then taking that ID and storing it in, your own database. So that's actually something I forgot to mention, that that's kind of one added thing, that when you use a third-party service, you still need to kind of have to do that work to synchronize kind of,
Exactly.
your source of truth of what constitutes a user versus, Firebase's. So that's a good point you bring up there. But sort of back to the first point about, what you should look at regarding like projects that have already been, kind of worked on for a while. I would say probably authorization is the first place to look. Like, make sure that it's, because this is not something that comes immediately. This is like that just happens automatically. It's something that you specifically need to write in your code, that, I as a user can't just query for someone else's. I can't just look at your request payload and kind of see that you're, okay, they're, looking for comments at this endpoint. Can I get a different comment if I just change this number in the URL? I think authorization is where a lot of student projects typically don't necessarily focus on right off the bat. I think rate limiting is also the second thing I would just add, because it's so simple to add, and it completely eliminates the possibility that someone can break your whole app just by, a for loop in Python firing off requests. I think I would also recommend kind of putting everything in a subnet and a VPC on AWS, just because that means that um, you don't need to worry about your database being compromised, because it's kind of within this walled garden, right, where you're just securing this one endpoint going in and out of. So I guess, yeah, subnet and authorization would be kind of the first things to look at. Or just
Awesome. Thank you so much.
ask someone to try to break your application.
Mm-hmm.
Is a good way to do it too.
Also, Ethan, do you have any recommended like password managers that, because I've been meaning to do that, but I ended up having like like varied versions of the same password in different like websites, and I want to change that.
Right. I think this is something where, people have a lot of their own personal preferences. I mean, I just honestly use like the Apple Safari keychain for everything, but I've also used LastPass in the past. I've heard good things about 1Password. It's really less about your choice of tool, more just the fact that you're using it is what's important.
Alex says don't use LastPass. Okay, I won't use LastPass.
LastPass has been compromised multiple times, and they I don't know if they sell your data or something, but they do some sketchy things. So yeah, use open source password. Also, hi, I'm Alex. I'm the other co-president of ISSS. I'm not just some random person, but yeah.
Hello.
Yeah, like Ethan said, 1Password is good. That's what I use. And then Bitwarden is one that you can self-host, and it's free and open source, so a little bit more secure.
Okay, awesome.
I think it's Kahoot time. All right. I'm a host this row. It's just 10 kind of quick, short little questions, but if anyone wants to hop on here. I think, and some of these questions should hopefully facilitate some, discussion. So I put in some trick problem, or not really trick questions, but hopefully something to talk about. Maybe give it a few more seconds and I'll click start. All right, is everyone who wants to be in this in this? I'm gonna take the silence as a no, so let's get started. I've never hosted a Kahoot before, by the way, so this will be interesting. All right, true or false? You should always implement your own cryptography. False. No. So authentication, you could sometimes implement on your own, but cryptography, the actual math behind what's going on when you're hashing and salting passwords, you don't know enough. People way smarter than you have built these, and we should trust them instead of doing it ourselves. Glad everyone got that one right. All right, true or false? If I'm using a cloud provider like AWS, I don't need to worry about my infrastructure security. Yep, it's kind of another freebie there. You still do need to worry about the security. You do kind of have the benefit of, things within this subnet. You need to worry less, right? Like you don't not worry at all, but it gives you some level of assurance that your database is not vulnerable to the outside internet. But you still do need to worry about it to some extent. All right, open source software is insecure because the source code is public. All right, cool. So this is, I actually forgot to make this point in the presentation, but for the purposes of most, kind of product focused organizations or startups, I advocate for closed repos unless that's kind of your business model revolves around open source. But open source software is actually, some would argue more secure because it's public, meaning that, because everyone can see it, people are sort of independently able to see exactly what's happening and to identify vulnerabilities and then publish those and then eventually have fixes more patched in upstream. So it's kind of a weird point. I could have talked more about open source software in the presentation, but code being public doesn't necessarily mean it's insecure. All right, it's possible to add security onto an insecure web app. Right, so you can, it's just harder, and it gets harder and harder the farther things move along. So I sort of urge you to think about it earlier or sooner rather than later. All right, true or false? It's okay to trust a third party to handle authentication. ISSS is kind of opinionated. Yep. So the important point here is your customers might not agree. This is where you kind of have to know your industry, know who you're selling to. Lots of companies I would hope probably don't want you using Facebook as your auth provider, but it's kind of more up to them, right? So it's kind of just a know your customer, know your market kind of thing. Right, mobile apps have a totally different set of security concerns compared to desktop applications. So the right answer is kind of. I didn't go super in depth to this at all, but one thing I think comes up a lot with mobile apps is like location data and just the fact that there are more literal sensors that could literally be tracking your heart rate and stuff that maybe you have to think more about that when you're building a mobile app compared to a desktop app. But this is kind of a opinionated question too, because the core principles kind of remain the same. Where data privacy, no matter what the data is, it's sort of something you want to be cognizant of. All right, Tiago's on fire. All right, it's okay for API keys to be in source code as long as the repository is private. Yep, and so this is false because, so even if you commit this relies on a few different things happening for it to be catastrophic. Is, if you commit an API key and then you're like, oh crap, I shouldn't have committed that. I'm going to make another commit and remove it. Git commits are kind of, snapshots of the code at that point in time. So even if you remove it, if that .git folder is still there, someone can just trivially go back and see, that commit that added the, the API key.
Is there no way to roll back like the entire repo?
You can, if you want to make people's lives difficult, you can do kind of a, you can rebase or kind of force push with that. But that makes the other devs' lives harder because then they can't pull. It just causes a whole sort of other set of problems. So if you do commit an API key, just go to wherever it was issued and just invalidate it, generate a new one. Is way easier than going through the trouble of trying to do some Git magic. And the reason that it's, even if it's private, private repo, sure, but what if my GitHub account gets hacked? What if another developer's laptop is stolen? This kind of thing. It's still this sort of goes back to the principle of least privilege, where ideally I shouldn't be able to, if I'm working at a company like I work at Lumos, I shouldn't be able, or I'm not able to go in and see our API keys for different things on AWS, because that's sort of like a resource that I'm locked out of because I don't need to know it to do my job. Let's see. All right. Ideally, who should be able to see real customer data? Again, it's kind of opinionated. It depends on your product. Yep. So CISO here, I should have maybe explained that. It stands for Chief Information Security Officer, which is someone whose kind of whole job is to be concerned about security all of the time. And it's not really reasonable to have them be the only person that can see data, because you might need more developers to be able to make kind of actionable decisions or be able to help debug things. But yeah, in general, don't give the interns access. They don't need it. CEO doesn't really need it either. Definitely don't give it to everyone in the company. I think we got two more. All right. It's okay for API keys to be in front-end source code as long as the source maps are disabled. Yeah, the answer is still false here. Source maps are kind of an orthogonal concept to the notion of having API keys in source. This is actually kind of funny. Let's see if it's still there. So I think the Insomnia Cookies website has their API keys in just the source code. I was looking at this last night. I saw it. But basically, yeah, I'll leave that as an exercise to the reader to find Insomnia Cookies API keys. Yeah, don't put them in source. There's no reason to keep your secrets in source. All right, last question. Which one of these is the most secure port to host your backend on? All right, so this one's this was kind of a trick question, or not really a trick question, but so kind of relating to the point I made earlier about security by obscurity is saying, okay, don't kind of just do weird unconventional things because they're hard to guess what you're doing. So I think this applies almost everywhere except for port numbers. So if you look at machines that if you just open a machine with port 80 or port 22 open, you'll just, if you leave it open on the internet and you leave it for a night, come back, you'll see just dozens of requests from mostly Chinese and Russian IPs just trying to just visit every computer they see and just sort of say, hey, like is this open? And so I think ports are the kind of the one place where having a random port number is totally fine, because that almost eliminates the possibility someone's just going to randomly stumble upon your application. And so the reason 4528 is the answer is because I just made that number up. All the others support, 80 is just for web, port 22 is for SSH, port 5432 is for Postgres, which are also sort of very commonly used. So yeah, make it random. All right, so here's the podium. Alex, I think I've read this article. It still kind of is. It helps. It doesn't hurt anything.
Wow, Yash got the last question for no reason.
For no reason. All right, cool.
Maybe you work with Postgres. I don't know.
Well, thank you all for participating in my first ever hosted Kahoot. That's pretty fun. And thank you again, Neil, for inviting me to come speak here.
Yeah, I just want to say big shout out to ISSS. Thank you guys so much for helping us out, like teaching us a lot about security. Thank you so much, Ethan. We really, really appreciate it. And I think we have a lot of work to do on maybe securing some of our projects in the next couple of weeks.
Sure. Feel free to reach out and ask if you have any questions. More than happy to help with any of y'all's projects.
You never will. And if anybody else here at TPEO is interested in ISSS, they're always free to join, and you can learn a lot more about cybersecurity. They're actually how I got interested in cybersecurity in the first place when I came to UT. So go to ISSS.io if you're interested in joining.